Class, this is part C and D. I'm doing them together in the third part. So it says the initial rate study is performed. The reaction data for the experiment is below. The reaction is known to be third order with respect, there we go, to H plus. Using this information and your answers in part B above, complete both of the following. I write the rate law for the reaction. So that's going to be rate equals K, and then it's going to be chloride permanganate H plus. And now we have to put in the orders. Now we know that this is a third order, so I can automatically put the 3 in here for the H plus. We know that from part B we had a 1 for this and a 2 for this. So the rate law is K, Cl minus to the second for the second order, MnO4 to the first for the first order, and H plus to the third for the third order. Okay, so that makes this a 6-order reaction because I add them all up as I go across. Most times, though, you will not see a 1 for a first order. It will just be written like that without the 1, because that's what we do in chemistry. We write stuff without 1s. So let's take a look at I2. Calculate the value of the rate constant for the reaction, including appropriate units. All right, I need some room. Let me scroll down. To do this, I'm going to leave reaction number, let's do reaction number 1, or trial number 1, like that. There, perfect. So all I'm going to do is I'm going to literally solve for K. K equals rate divided by all of this stuff. That would be the Cl minus to the second, the MnO4 minus to the first, and the H plus to the third. And then I just simply, I just throw in the numbers. So that means 2.25 times 10 to the negative 8th. That's going to be molarity per second, I think. Let me go back up and check. Sometimes it's molarity per minute. Molarity per second. It says rate of disappearance of MnO4 with molarity per second. So then on the bottom, I have 0.0104, and because that's chloride, that's squared. And the next one is 0.00400, that's to the first, and 3.00. And these are all, by the way, molarity, like this, and that's to the third. So that means I have m squared times m cubed. Okay, what we can do is we can get rid of this and get rid of this. Okay, so as far as the units are concerned, now I need to scroll down a little bit more. And as far as the units are concerned, it looks like when I do all of the calculations, and this really does take, I mean, you got to be careful with this. I end up with the number 1.93 times 10 to the negative third, and I have m squared and n cubed on the bottom, which is going to equal m to the minus 5. That means 1 over m to the fifth, and then seconds to the minus 1. And that's how we get our number and units. Because I just cancel all the m's that I need, and I end up with 5 on the bottom and 1 s on the bottom. And that's what the negatives mean. Okay. Excellent. Let's take a look at D while we're here. Is it likely that the reaction occurs in a single elementary step? Justify your answer. Well, I got 2 answers for this, and the answer is no, it's not likely that the reaction occurs in a single elementary step, and I got 2 reasons why, is what I mean. Take a look at this. The order for H plus is third order. Okay? That does not match up with the coefficient. The order for Cl minus is second order, and the order for this is first order. This is the only one that matches up with the coefficient. Okay? Because of that, I would say this is not the elementary step, because elementary steps, will match up the coefficient and the order. And that clearly did not happen here, and that's the first reason why. So let's go back down. Let's go back down here and say, I need more room. The answer is no. No. My first reason for that is coefficients do not match reactant orders. And they would if there was only one elementary step. Okay, my second reason for saying definitely no, it's not a single elementary step, is that you remember me saying in the notes that intermolecular reactions happen rarely. Because getting three pieces to combine, three things to combine in exactly the right orientation and energy ends up being very difficult for that to happen. So take a look again at, we're going to take a look at the equation in just 1 second, but it says intermolecular reactions are very rare, rarely happen, and take a look at how many pieces we have here. So if this were just one elementary step, it would look like, here I have 8 hydrogens, 4 chlorides, and 1, get rid of that, and 1 permanganate. That's 13 different things combining at all the right orientation and the right energy. That's impossible. Yep, I said it. It's impossible. So 13, if termolecular means 3 parts. If 3 parts are difficult for coming together, then 13 is not possible. So this definitely happens in elementary steps. Okay, 13 pieces or 13 parts, just not possible to come together in the right orientation and with the right amount of energy. There's just too many pieces that would not fit together. So 13 parts, not possible to come together. Those are my 2 explanations for why it is not likely. So it's definitely not likely that reaction occurs in a single elementary step. Okay, thanks a lot, guys, for paying attention. Good luck. I hope you did well on this.